Welcome to the 1989 Ford Long Lead Press Show, the yearly event at Ford showcasing our new vehicles and engineering features to the national and international automotive writers and magazine editors. We've come back again this year to use this event to take a look at the new vehicles and the important service features that you'll need to be aware of. Like last year, the people gathered here are taking advantage of the chance to see the vehicles, drive them, draw conclusions, compare their thoughts, and in general, prepare their stories for publication when the new vehicles actually appear on the market. They've got plenty to look at this year too, with the all-new Thunderbird and the new Taurus SHO. We'll be looking at these new vehicles, along with the new 3.8-liter supercharged engine, the 3-liter SHO engine, the 2.3-liter dual-plug engine, the E4 OD automatic transmission, and the M5R2 manual transmission. In addition, we'll examine other engineering innovations that make 1989 an exciting year for Ford Motor Company. Let's begin, though, with the most exciting vehicle to hit the American road in years, the new Thunderbird. The Thunderbird is available in 3 versions, Base, LX, and the Super Coupe. The Thunderbird has been completely redesigned and features a supercharged engine in the Super Coupe model, 4-wheel independent suspension, larger brake assemblies, and an overall look that spells world-class all the way. The low-aero look is not an illusion, as the cowl, nose, and overall silhouette are all lower than last year, and the windshield is at a much lower 63.9-degree angle. Also, the wheelbase has been increased, although the vehicle length is shorter. The effect of the new suspension system is immediately noticeable. Steering, handling, ride, and down-the-road stability are greatly enhanced over previous models. Let's take a closer look at the front suspension. It's called the SLA, an abbreviation for Short Long Arm. It's a new design for this vehicle that allows for the distinctively lowered hood. There are several key points to be aware of on this suspension. They include new suspension bushings that are Teflon coated to eliminate suspension friction and allow them to pivot at a low torsional rate, plastic-lined reduced friction ball joints for improved ride, Teflon-lined and lubed stabilizer bar bushings and ball joint links for improved roll control and handling, a double isolated tension strut for reduced impact harshness and road noise, automatic adjustable suspension on the Super Coupe, higher caster angles, 3 times the amount used on the 1988 Thunderbirds, for improved down-the-road stability. Also, the caster angle increases as the vehicle is loaded. And the front suspension is fully adjustable for caster, camber, and tow. Adjustment of the caster is accomplished through nuts on the tension strut. Tow adjustments are made by turning a sleeve on the tie rod. And camber adjustments are executed through a cam assembly. The Thunderbird's new independent rear suspension contains many of the features that were mentioned for the front suspension, including the special slippery Teflon-coated bushings, Teflon-lined and lubed stabilizer bar bushings, and the automatic adjustable suspension as featured on the Super Coupe. The suspension is totally independent, and it consists of a lower H-arm, upper arm, and stabilizer bar. The base system has a 1-inch diameter stabilizer bar, but the Super Coupe is equipped with a 1.1-inch diameter bar. The stabilizer bar is tubular, not solid, which decreases the weight of the suspension without disrupting its performance capabilities. Cradled into the rear suspension is the new axle assembly that's attached by half shafts to the rear wheels. The axle assembly is mounted to the suspension subframe through special rubber bushings. The subframe is then mounted to the vehicle through additional rubber bushings. This double isolation mounting prevents axle and driveline NVH from being transferred to the body, resulting in a smooth, vibration-free ride. On this suspension, the lower arm takes all the load, while the upper arm is for camber control and lateral location control. In other words, it keeps the tire on the road, maintaining the maximum tire patch area. The Thunderbird rear suspension is adjustable for camber and tow. These adjustments are made by cams. These adjustments are critical for proper tracking, directional stability, tire wear, and overall control. If service on the suspension system or driveline is required, it is essential that the adjustment of the rear suspension be checked. Another point about service is that if the rear suspension bushings are replaced, they should be tightened with the suspension in the curb or loaded position. Tightening them with the suspension hanging would cause them to be in a stressed condition when the suspension is in its normal position. The rear axle assembly differs between the base and LX model and the Super Coupe. On the Super Coupe, an 8.8-inch axle is used. Base and LX utilize a 7.5-inch axle housing. Drive to the rear wheels is through equal-length half shafts that are attached to the axle and wheels by constant velocity joints. A tripod-style joint is used as the inboard joint, while the Resepa-style joint is used on the outboard. Service on the axle assembly does not differ to any great extent from conventional axle and differential assemblies. A point to note, though, is that the half shafts on the Super Coupe are not equal in diameter. A small diameter shaft is used on the left side, whereas the right is slightly larger. This is due to the torque load characteristics caused by the supercharged 3.8-liter engine. Half shafts are the same diameter on the base and LX models. An important point to note about service is that the vehicle should not be run on a hoist with the suspension hanging. Operation of CV joints at extreme angles can cause severe damage to the CV joints. Make sure that whenever the vehicle is lifted, the suspension is supported. To complement the suspension system, Thunderbirds, except for the base model, are equipped with the speed-sensitive variable assist power rack and pinion steering system. The steering system provides a high degree of assist at low speeds for ease of maneuvering and parking. At higher speeds, the amount of assist is reduced to allow improved road feel. This system is referred to as the EVO, which stands for the Electronic Variable Orifice. This is the controlling device of the system. It mounts to the power steering pump and replaces the power steering pump valve outlet. The EVO regulates the hydraulic flow according to commands from the control module. The control module for the system processes inputs from a transmission-mounted speed sensor and a steering wheel rotation sensor mounted in the steering column. Using this information, it commands the electronic variable orifice to provide the required steering assist. The control module for the system is mounted in the luggage compartment. There is also a service connector mounted in the upper glove compartment, which can be used to diagnose system malfunctions. A service diagnostic lamp is used at the diagnostic connector to access codes and to perform the diagnostic steps on the LX. EVO diagnostics on the Super Coupe are different. On the Super Coupe, the EVO control module is integrated with the automatic adjustable suspension system module, which is also mounted in the luggage compartment. Diagnostics on the system are accomplished using the STAR or Superstar 2 diagnostic testers at the automatic adjustable suspension diagnostic connector on the passenger side shock absorber tower. So far, we've concentrated on suspension and driveline components. But the heart of the Thunderbird is its high-performance 3.8-liter V6 engine. This engine was improved extensively in 1988 and has received further upgrades for 1989 that include sequential multi-port fuel injection for greater efficiency, roller tappets, and 2 weight-saving features, magnesium rocker covers, and an aluminum hub crankshaft damper. Another point to note is that the balance shaft, added in 1988, has been removed from engines that are installed in rear-wheel drive applications. The balance shaft remains in 3.8-liter engine front-wheel drive applications. However, the major change for the 3.8-liter engine is the addition of the supercharger for use in the Super Coupe. The supercharged 3.8-liter engine drew many questions from the assembled writers and editors here at the Long Lead Press Conference. They quizzed Ford engineers extensively about the engine. The engineers were happy to point out the benefits of the engine, beginning with the fact that performance is similar to a larger V8. It is characterized by smooth performance with instant response at all times. The engineers noted that with a supercharger there is a complete absence of turbo lag, which was present in the Turbo Coupe. But the true